How's it going, guys? Today we're going to be going over another problem called battleships in a board. This is a question that's actually asked by Google right now, and it's a graph problem. It's super common to see graph problems on your interviews, so this is a good one to know. So it says, given a 2D board, count how many battleships are in it. A battleship is represented by X's, empty slots are represented by periods. You may assume the following rules. So we'll receive a valid board made up of only battleships and empty slots. Awesome. Battleships can be placed horizontally or vertically. So we're not going to have any like weird squiggly battle shapes. We're not going to have any kind of like circular or anything weird like that. So we're just vertical and horizontal. And at least one horizontal or vertical cell separates two adjacent battle cells. So that means that two battleships are never going to be like directly against each other. Cool. So let's look at one example here. So if this is our board, we would return two because there's two battleships, right? One is the top left corner, and then the other one is just this vertical line down the column here. So we just return two. That's easy enough. Here is an invalid example, so we will not get something like this. So this is an example of an invalid board because battleships always have to have a cell separating them. So we will try and do this follow-up after, but first I want to try and formulate a recursive solution to solve this. So graph problems are tough, and people typically get stuck on them. People think that they're kind of hard. But I think the reason really why I wanted to do this question in particular is because this kind of models a lot of graph problems. And if you guys understand how to do a problem like this, you guys can take this and apply it to a whole bunch of other problems that have to do with graphs. So again, this is a medium difficulty problem. I don't really worry too much about the difficulty. I'm just showing this because I really think that this is a good problem to know, to kind of just take and apply to other graph problems that you might see. Because traversing a graph is pretty trivial once you know how to do it for one example. It typically ends up being the same. So we need to think about how to not recount battleships, right? Like we could traverse this entire matrix and just count X's, but the problem is the first battleship is made up of one X, and the second battleship is made up of three. So we don't want to count four ships, right? We just want to count two. So we can use what they said here, which is that we'll have at least one cell separating the battleships. So what we can try and do is every time we see a battleship, which is an X, right, we can try and sink that ship. So we're going to find an X and then sink that ship, and then continue traversing, find the next ship, sink it, and continue while we haven't gone through the entire graph. So once we've gone through the entire graph and have counted all the battleships and sunk them, we basically have the count. So what we can do is if we see an X, we just want to recursively sink all of its neighbor cells. And once that all those recursive calls return, we will have counted one battleship. And then we continue, and the next time we find an X, it has to be a new battleship. So let's start writing the solution. So we want to return an integer, right? So I told you guys before, but I always like to just immediately declare the value that we're going to return. So I say int num battleships, and we're going to set it to 0 because we haven't found any yet. So now you could have some error checking here if you want. I think the way we're going to write the solution will be handled anyways. But now we want to traverse the matrix, right? So we can do that easily with two nested for loops. So we'll say for int I equals 0, while I is less than board.length, I plus plus. And now we have an inner loop, so for int j equals 0, while j is less than board I.length, j plus plus. So now we're traversing this matrix, and we're only interested in X's, right? We don't care about dots. Dots don't mean anything. It's just empty. It's basically the ocean. It's not a battleship, so we don't care. So the only time we're interested in something is if it's an X, so we can check that. So if board of ij is equal to an X, and I think it's capitalized. Yeah, capital X. So if we find a capital X, we want to increment the number of our battleships. So we'll say num battleships plus plus, because we've found a battleship. So now what we're going to do is we're going to call a recursive function to sink this entire battleship, and then we'll continue traversing the matrix. So we'll say sink, and we need to pass the board so that we can change the board, and I and j so that we know the indices we're at. So now we'll start writing our recursive method. So we'll say public, this is going to be void, right, because it's not going to do anything except change the board. And we'll say sink, and it's going to take a character matrix called board and an integer I and an integer j. So what are we interested in now, right? So this is a recursive function, so we need to have a base case. So what's our base case? One thing that we need to realize is we're only interested if the neighboring cell is also an X, right? If it's a period, we're done. But the other thing we have to worry about is our bounds, right? We can't go outside of the matrix. So we need to check those two things. We need to check our bounds, 1, and 2, if the cell we're on is even an X or not. So we can have a quick if statement to represent our base case. So if, and we'll just do the bounds first. So if I is less than 0, right? So if we've gone out of bounds upwards, or I is greater than or equal to board.length. I like to do greater than or equal to, just to be super safe, but you should just be able to say equal to. So if I is greater than or equal to board.length, and I typically do that in case like somehow the value jumps by 2 and it doesn't actually execute. So just to be safe. So if I is greater than or equal, if I is less than 0, meaning we've gone out of bounds upwards, or if I is greater than board.length, meaning we've gone out of bounds downwards, or j is less than 0, right? So if we've gone out of bounds to the left, or j is greater than or equal to board I.length, so if we've gone out of bounds to the right, or finally if board of ij is not equal to an x, then we don't care, right? So we'll just return. Otherwise, if we get past this if statement, we definitely have to be on an X. So what we want to do is we want to change the board so that we don't come across this cell again and try and count it again or try and do anything with it. So we'll set the board of ij equal to a period. So we'll say board ij equals a period, not an X, a period. And now all we need to do is sync its neighboring cell. So to do that, we just make a recursive call to those 4 neighbors. So we'll say sync board I plus 1j, sync board I minus 1j, sync board I j plus 1, and sync board of I j minus 1. So now, once we've gone through this entire matrix, right, finding an X, syncing its neighbors, continuing, finding another X, syncing its neighbors, continuing, all we have to do is return our number of battleships. So we'll just return num battleships. Let's see if this works. Cool, it does. So that's the kind of like naive solution. I think honestly, if you got this far, this is a really good sign. I don't think you would really be docked for coming up with this next thing that we're going to go over, but it's good to know. So there's another small piece of information that's very valuable, and that's that the battleships can only be placed horizontally or vertically. So that means that because we're traversing the matrix like this, right, top to bottom, left to right, we know that if we are on an X anywhere in the matrix, let's say over here, if we're somewhere in the middle of the battleship, we had to have come from right above us or just to the left of us, right? So because of that, we can kind of skip all those recursive calls and only count the first X in each of the battleships. So what we can do here is we can say if our, so we'll just modify the solution we have now. So we're still going to return the number of battleships, right? But so if we're on a period, we don't care. So we're going to continue. And now the next thing we want to check is if I is greater than 0, right? Because we can't be to the left, we can't be above if we're on the first row. So if I is greater than 0 and board of ij, so if I is greater than 0 and board of ij is equal to an X, then that means we're already counting a battleship, right? So, no, sorry. If I is greater than 0, meaning we can check the cell above us. So if I is greater than 0 and board of I minus 1, so the cell above us is an X, then that means we're still counting the same battleship. So we also want to continue. And now finally, we want to have the same kind of check, but for the left, right? Because we could have only come from the left because we're traversing left to right. So if now j is greater than 0 and board of I j minus 1 is an X, then that also means that we're still counting the same battleship, but this one is placed horizontally. So we can also continue. Otherwise, if none of these if statements execute, that means that we found the first X in a battleship. So we want to say num battleships plus plus. So now once we've gone through the entire matrix again, this num battleship should have the actual number of battleships total. And it does. Awesome, guys. So this is how to solve battleships on a board. Again, this is super common. Take this problem, make sure you understand it. Use it as a template to solve other graph problems. This is asked by Google. I hope it was helpful. If you guys have any questions, any comments, anything I could do better, any way I could help you guys, leave a comment down below. I would love to hear some problems that you guys would like me to solve or any topics that you might need help with. All right. Good luck on your interviews, guys, and I'll see you guys next time.
Look like a pussy, a suit and a tie. Yeah, we're so gang and we're doing this shit, boy. We ride with this bitch and we ride till we die. Look at the shit that I'm doing, only one left, and you know that I'm alive. Look at the shit that I'm doing.